Hi, everyone. Today, we're going over one of the functions that we wrote in our linked list video. So if you haven't watched that video, I recommend you watch it first. With that being said, let's get started. We saw that in the push function we wrote, we would have to traverse the entire linked list in order for us to add a node at the end of the linked list. If you could imagine, if we were to have 1 million nodes in the linked list, then we would have to traverse the entire linked list as we saw and check if the field next of each node contains a value that is equal to none. And you're probably thinking right now, this process takes a lot of time, and I totally agree with you. So is there a way to optimize this function such that we wouldn't have to traverse the entire linked list? What I mean is that, can we write it in a way that takes constant time rather than linear time? So let's take some time to think about it. What if we hire another person whose duty is to be at the last node of the linked list? And each time we add a node, we give that node to the new person. And you're probably thinking right now, what is this guy is talking about? So let me show you what I mean. Let's say we have this linked list and the new person we hired whose name is Tail. Tail's job is to point at the last node for each new node we add to the linked list. So if we allocate a new node and assign it to the pointer new node, now Tail assigns the field next to point where a new node is pointing to. Let me show you what I mean. So if we go ahead and declare a pointer and name a new node, and memory allocate a node for us with the value 5. And now let's say new node point to this node. Let me change the color to point to this node. Now, what we can do, Tail access the field next and assign the field next to point to the new node that new node is pointing to. And that's it. All right, now we have an idea how we could do that. So let's go ahead and write it in code. Okay, now let's go ahead and delete everything in this function for now. And then add the person Tail and assign none to it. And then we're going to change the name of this function to show elements. And we'll keep and delete this one and then do self.head. And then we'll just do this like that. And then we can keep it the way it is, but let's do it this way. And now let's write the push function. So go ahead and declare this pointer and have the elements and pass an element to it. All we have to do is, if not self.head, then what we do, we say self.head is equal to new node, else self.tail.next is equal to new node. And then outside the F statement, we say self.tail. Oh, actually, let's break one line down. Self.tail is equal to new node, and then we return. So let me go over this function one more time. We declare a pointer new node that is a type of that class node, and then we assign the node to this pointer. Now we're checking. Go ahead and do reference and access the field head and see if the address is equal to none. If the address is equal to none, which is evaluated to false, and then we convert it to true, and then we get inside here, then we assign the address to the field head. and then outside here, and then we jump in here, and then we assign the field, and then we assign the new node to the field tail. And that's how we do it. That's how we optimize the push function to give us the ability to insert node or push node at the end of the linked list in constant time. So let's test this one. Now let's say linked list is equal to linked list, and then we can say for num in range of 1 to 8 linked list dot push of num. And then once we're done, let's go ahead and display each element inside each node. Dot show. And then that's it. All right, let's test this right now. We'll do Python 3. And there you go. We have 1, 2, 3, 4, 5, 6, 7. So let me show you exactly in details what's going on in here. All right, we have the push function. We also have the for loop that we saw in the example. Now let's go step by step. Now we call this function in here the push function. Now we come in here, we say new node is equal node, and we pass the element. In that case, the element is 1. So we have new node in here. It is a pointer that points to the new node with the value 1. Now what happens is that we come to this line and we say if not self dot head, if head contains a value that is equal to none, that convert it and convert it to true, get inside here. Now we assign the field head to point to a new node. So now we point to here, then we say self.tails is equal to a new node. Now we take self.tail is equal to new node. Now, and then we continue what's inside the function. Now we return, we get out of the function. Now this variable goes away. And then we go ahead and we do another, and then we come in here again, and then we call the function, we pass 2, we are, here's where we are in the function. We say a new node is equal node and pass the element 2. So now we have new node that points to a node, which is in this case 2. This is 2. Now, what happens when we come to this line in the function, we say if not self.head, which is right now self.head actually has an address that does not equal to null, so we don't get inside this function. Otherwise, what happens is that we say self.tail.next, go ahead and dereference all the way to the field next and point it to where the new node we allocated in here is pointing to. We take this and then we point it here, and then we continue down, and then we say self. Now we are right here, and then we say self.tails is equal to new node. Now, rather than just pointing here, what happens? We point to where the new we point to where the new node is. Now we get out of the function, and then this goes away. And then we continue doing the process until the end of the for loop, and then that's all. I hope you all have better understanding between the two functions. And if you have any other questions, please let me know, and I'll do my best to answer those questions. Thank you for watching.